Chapter 3 deals with graphing functions and relationships. So the very first unit, graphing relationships, is basically discussing how we can, on the coordinate plane, which is the XY coordinate system, where that's the x-axis is horizontal and the y-axis is vertical. Quadrant 1, just as a quick refresher, quadrant 2, 3, and 4, you plot points, x comma y. Basically what we're talking about with this unit is the relationship between the y and the x that you input into the equation. So let's look at some definitions. A function is a relationship basically, or an equation, where x and y are related to each other. So before we go into the continuous and discrete definition, let's look at this. If I was to say to you, y is equal to 2x plus 1, for example. What we're talking about is the relationship between the input, what you put in for x, and the output, which is what you get for y. So if we were to choose, let's say, 0, -1, and 2 as our inputs, remember x is the input and y is the output. The x is the independent variable. The y is the dependent, because y, the output, depends on what you put in for x. So if we put 0 into x's value, we would get 0 plus 1, which is 1. So 1 is the output. If we put -1 into x, you would get -2 plus 1, which is equal to -1. And so when x is -1, y also happens to be -1. If you put 2 in for x, you would get 2 times 2 plus 1 is 4 plus 1, which is equal to 5. So that means that when x is 2, y is 5. The input is the x value. The output is the y value. These here this is a table of values, and it's a function. This is the function because the output depends on the input. Now, if you have a function where the graph has no breaks in it, it's continuous. It's basically if you can graph it without picking up your pencil. So, for example, if I was to give you a table of values where we're going to say that this is, as time goes on, the tree grows in inches. So after 1 month, the tree may be 2 feet. After 2 months, the tree may be 3 feet. But what's happening is that in between the 1 and the 2 in months, it's still growing. So in reality, it's continuing to grow. So there are spots in between that are being filled in. That is a continuous graph. A discrete graph would be, as they discuss here, a graph where a function has isolated points. So let me give you an example of that. If I was to draw and say that we are going to measure, let's say, how many bracelets you're going to create. So the number of bracelets that you make are going to cost, or you're going to get paid in dollars. Let's say for every 1 bracelet, you get $2. So if you make 1 bracelet, you're going to make $2. If you make 2 bracelets, you're going to make $4, and so on. Now, in between 1 bracelet and 2 bracelet, you're not going to get paid for 1.5 bracelets, so there's no point that is going to be labeled there. You're not going to be paid for 2.5 bracelets or 2 1/4 bracelets, so no point is going to be there. This is a discrete graph. It only has isolated points because the times in between cannot be filled out. Unlike our tree explanation, between 1 month and 2 months, the tree may be growing, but they're growing spots between it. So in reality, it's a continuous graph. So that's the difference between a continuous and discrete graphs. Discrete just have points, and continuous is a line with no breaks in it. These are some words that are relating graphs to situations. If you hear the words was constant, it means that there's a horizontal section. So if I said to you, we kept going at an upward steady rise and then we were constant for a specific amount of time, that means that that specific amount of time was constant is horizontal. And this is going to make more sense when you see the graphs. Stayed the same is also horizontal. Slanting downward means that it dropped sharply. So let's look at this for example. It says that the air temperature was constant for several hours at the beginning of the day and then rose steadily for several hours. It stayed the same for most of the days before dropping sharply. So we're trying to figure out which one of these represents. Well, if it was constant for several hours at the beginning, it means this. This could be the same thing. It's definitely not this one because at the beginning, this looks like it made a sharp rise. So it's not C. It was constant for several hours and then rose steadily. So it could either be this or it could be this. So both A and B are still in it. And then it says that it stayed the same for most of the day before dropping sharply. So if we were to look at this situation, it looks like it's staying constant, it's rising steadily, and then slowly dropping. Here, it's staying the same, rising steadily, and then it stayed the same for most of the day. This part here stayed the same for most of the day before dropping sharply would be the situation that they are referring to. So your job is going to be to, first of all, try to figure out what graphs are represented by situations and also sketching graphs. Let's look at this example. They want us to sketch a graph for the situation and tell whether the graph is continuous or discrete. Remember, continuous is a solid line at some point. Discrete is where you have points because in-betweens don't get measured. Simon is selling candles to raise money for school dance. For each candle he sells, the school gets $2.50. All right, so for each candle, one candle, you get $2.50. So, first of all, who is the dependent and the independent variable? Remember, the dependent is the output. The independent is the input. Independent would be X, dependent is Y. So in this case, the amount of money that is being sold depends on the number of candles that are sold. So that means that if the dollars depend, that is the Y. So that means that the amount of dollars made would go here, and the number of candles go here, because the number of candles is the independent value, and the amount of money is the dependent. For each candle, he gets $2.50. So that means that if I have one candle, I make $2.50. If I have two candles, I make $5. In 3 candles, I make $7.50. Let's graph that for now. 1 is $2.50. 2 candles is $5. 3 candles is $7.50. 4 candles, if we continue making it, would be $10. 5 candles is $2.50 more. 6 candles is $15. 7 candles, 8 candles is 20. 9 and 10 is 25. Now, in this case, we are not going to connect the dots because if we connected the dots, we are basically saying that he's going to get money for making a part of a candle. So like at 1.5 candle, he would make something in between. He's not making money in between, so we're not really going to graph in between. So we would remain as just the dots, which would make this a discrete graph because you're not connecting the dots in between. And the reason you're not connecting the dots in between is, again, if you connected the dots, that would mean that you've got in between these spots, you would have dots representing that you're getting money for a part of a candle, which you're not. So that one is a discrete graph. Let's look at the next one. Angelica's heart rate is being monitored while she exercises on the treadmill. While walking, her heart rate remains the same. Okay, so it's constantly the same. As she increases her pace, her heart rate rises at a steady rate. When she begins to run, her heart rate increases more rapidly and then remains high while she runs. She decreases her pace and her heart rate slows down and returns to normal. So the rate of her heart depends on speed of her walking or running. So that means that the heart rate, which is dependent, is the y, and the speed, even though it's changing, is the independent. So here we would put speed of walk or run or exercise. Maybe that would probably be a better word, exercise rate. And here's the heart rate. So she's on a treadmill. So as she's walking, it's going to stay the same. As she increases her pace, so as this goes up, she increases more rapidly. So it's kind of going to go up a little. And then it remains high while she's running. And then as she decreases, it starts slowing down until it remains after constant. Now in this case, you notice that there's obviously as she's walking, her heart rate is going to continuously be at something. It's not going to be dots, it's continuous. And so this would be considered a continuous graph. Notice we didn't have to put any numbers or anything down at the bottom. We just know that as she is walking, heart is steady at a specific rate. It's not going to be at 0 because her heart is moving. It's constantly beating, so you're not going to start at 0 and go up. It's going to just be constant at a specific amount. Then it goes up as she exercises, and it stays steady, and then it slowly starts decreasing until it goes back to her starting. And again, this is continuous because of the fact that you do have a heart rate in between. In between, there's a heart rate going on. Unlike here, in between, there's no money being made for parts of candles. Okay. For these situations, what we're going to be trying to do is just trying to identify what it is that we're looking at. So as we look at this, we notice that time increases, and we're talking about water level. We know that y depends on x, so the y-axis is the water level, and the x-axis is the time. So we could say something like, over time, for situation 1, red, the water level increased rapidly. Maybe this is because it was raining. And then at the second part, the water level remained constant for several minutes or hours. And then all of a sudden, the last part, the water level decreased rapidly. Very simple. It's not really looking too much into it. Now, possible situation, that's going to be really up to you. Like I said, it could be maybe during the rain, during a storm, the rain filled the water level. And you can come up with any situation that would make this true. So it filled the water level constantly. My situation was during a storm, the rain filled the water level constantly. That's what this is going on here. It stopped raining for time. After several weeks of dry weather, water started evaporating constantly or consistently. So that it's any situation really that you can. So for the independent practice, it's going to be pretty straightforward. It's just going to be asking you to choose the graph that best represents each situation. And same thing with 4, 5, 6, and 7. Number 4, you're going to try to create a graph. Remember, there's really, the only thing that could be wrong is if you misinterpret whether it's continuous or discrete and whether you incorrectly place the dependent and independent variables. But for the most part, like this one where you're writing a possible situation, there's lots of situations that you can come up with. Try to be as creative as possible. Definitely write them down and let me know what your situations are. And let me know if you guys have any questions. See you tomorrow.